with learning curve here, the various topics that it could be used, or there are various ways it can be used. One of the ways that we can use it here is to simply do what? To identify the price of a product, so that you can do what? Ensure that there is competitive what? Bidding. Alright, ensure that there is competitive what? Bidding. So let me highlight the other some uses of learning curve. Let me highlight some of the uses of what? Learning curve. Now this concept here of learning curve is very common in your exam papers. We will see it further. We will see it further when we talk about what? Target costing. We will also talk about it when we introduce the concept of what? Variances. When we also introduce the concept of variances. So this is not limited to this. There are other uses of that. Now, one of the uses of learning curve that I have just mentioned here is that you want to identify the price of a product. So here, product pricing, to ensure what? Competitive bidding. To ensure competitive bidding. That is the first use of learning curve. You want to identify the price in which you're going to charge a what? A product. Then the second use of it is to determine labor what? Remuneration. And labor remuneration here is simply the amount people engaged to work will be compensated and paid. For example, here the labor owed to the employees will be 116, 291, 600 and what? 10 for work scheduling purposes. For work scheduling purposes, where you want to identify and to predict the average time that a job or a duty will take, so that you can correctly schedule it and do what? And assign it. Then it could also be used for performance evaluation. It could also be used for performance evaluation. Where you want to identify or to compare the performance that is expected with the performance that is actually obtained. Okay, or you want to simply measure performance. You want to measure performance. All right. The fifth use of learning curve is to set realistic standards. To set realistic standards for labor. Where you will say, if I give my employees 1 day to work or a certain job to work, how much time can they afford to take? Can they take more than they expected, or will it take less than they expected? Why? Because you will give them realistic what? Standards. You don't want to put too much expectations or too low expectations than what they can, what the employees can be able to realistically achieve or attain. What are the factors affecting learning curve? Factors affecting learning curve. The factors affecting learning curve. The factors affecting learning curve. Number one is an individual capabilities. Individual persons. The individual persons here affect what? Learning curve. Okay. There are people who tend to be very, very fast, and there are others who are less faster when performing their duties. And so that in itself will affect what? Learning curve. A person's what? Capabilities and skills and what have you. Number two are the working conditions that have been put in place. Working conditions. The working conditions, are they favorable or are they conducive? Are they hostile? Are they good or unconducive? Number three is the levels of remuneration. Levels of remuneration. The rate of pay will also affect learning curve. Number four is the level of what? Technology changes during production, or change in technology of production. The rate at which technology is doing what? Changing. Then number five is employees who turn over. Employees turnover, the rate at which employees join and leave, or leave and join an organization. Leave and join an organization. An organization. Right. Those are the uses and the factors affecting what? Learning curve. The uses and factors affecting learning curve. So the assumptions of, or rather the factors affecting learning curve and the uses of what? Learning curve. Now similarly, there was a question tested on learning curve of August 2023, question 4. Of August 2023, question 4, which is also a combination of two items. One, the learning curve, and target what? Costing. And target costing. The combination of having what? Target costing. That you can attempt, and that we will also attempt when we will be talking about what? Target costing. That will also attempt when we will be talking about target what? Costing. About target costing. November of 2019, question 3A. November of 2019, question 3A. The question is saying, the assembly department of Lenkuris course has designed a new concept in racing bicycles with the intention of selling them to professional teams. The estimated cost and selling price of the first racing bicycle to be manufactured and assembled is as follows. You have your materials, your assembly, labor, which is 12 hours at 300 shillings per hour. Manufacturing overheads are 150% of labor cost. Profit markup is 6,000 with the selling price of 21,000. It is expected that the material cost per bicycle is to remain constant irrespective of the number of bicycles manufactured. The management expects the assembly time to gradually improve with experience and has therefore estimated an 80% learning curve. A racing team has approached the club's assembly department and made inquiries on the following quotations: the price of the second bicycle if the team purchases the first bicycle assembled and immediately places an order for the second bicycle; the average price of the third and fourth if the team waits until the first two bicycles are sold to another; the price per bicycle if the team places an order for the first 8 bicycles. Right. The hours of the first bicycle is 12 hours. So the first part of that question, the price of the second bicycle if the team purchases the first bicycle assembled and immediately places an order for the second. Price of second bicycle. The price of the what? Bicycle. So you'll say y 12 times 2. Then the second bicycle here, you're going to raise 2 by the log learning curve. And have you been given the learning curve? No. Need to determine b, which is log 0.8 divided by log 2. Log 0.8 divided by log what? 2. Which will be how much? Sorry. Times 12. Now this is what they're saying. The price of the second bicycle if the team purchases the first bicycle assembled and immediately places an order for the second bicycle, and immediately does what? Places an order for the second what? Bicycle. Okay. The price of the first, the total time of the first will be what? Because this is specifically the second bicycle, This is specifically the second bicycle. It will be 12 hours. So therefore, the second bicycle will take how much? 7.2 hours. 7.2 hours. So therefore, you want your playback, your cost. So you serve the material cost. Your material cost is 6,000 per bicycle. Your labor cost 7.2. You multiply by who? 300, 2160. You had manufacturing overheads which is 150% of labor costs. Which is 3240. So that's your total cost of the second bicycle. $11,400. Then you need to add a profit what? Markup. Your profit markup will be 6,000 divide by the total cost of the first bicycle, 6,000. The total cost of the first bike was 6,000 plus 36 plus 54 times what? 11,400. So what we have done, we have expressed this what? Markup, which is a percentage of costs. But for the first bicycle, the markup was 600 divided by the total cost, okay, or 6,000 divided by the total cost, which is basically 40%. It is an average of 40%. So therefore, the markup for that bicycle is 4560. So the total cost is 5,960. 5,960. The second part of that question, they are saying the average price of the third and fourth bicycles if the team waits until the first two bicycles are sold to another team. Average price of what? Of third and fourth what? Bicycles. The average time of the third and the fourth will be the total time for the fourth minus the total time for the second, divide by what? Divide by the number of bicycles, which are how many bicycles? 2. The fourth time, what will you do? The first was 12 hours times 4 raised to power 0.3219 plus 1. The second, remember the end of the second is the beginning of the third, and that is why we are taking the second, which was 19.2. 19.2 hours. This is the 30.72 hours. So therefore, the average time for third and fourth will be 19.2. In fact, the average price for the third of the third. So here should be the third here of the third which will be the price of the fourth, which will be the price of the fourth. Yeah, just a moment. So this should be the that. Okay, that way. So we're going to determine the price of who? The third and the fourth specifically, but we know the fourth will be the difference between the third and the fourth, which in this case is that plus 1 3 to the power that times 12. So 25.72 what hours. So the average price for the fourth will be 30.72 minus 25.72 minus 1, or divide by 1 rather, which basically means the fourth is taking about how many hours? 5 hours. Let's get the average price for the third vehicle, bicycle, which will be, this is the fourth, the average price for the fourth. This will be the third minus the second divided by the number of who? Bicycles. The third was how much? 25.72 hours. The second was how much? Here, 19.2 hours. Find. So the average of the third will be 6.52, will be 25.72 minus 19.2 divided by 1 bicycle, which is the third. So that will give you 6.52 what? Hours. Let's now get the cost. So here we'll write the third bicycle. We start with your direct materials. Your direct material will be 6,000. Labor cost. That bicycle took 6.52 hours. You multiply by your rate of 300. Manufacturing overheads. Manufacturing overheads, which is 150% of your labor. Then we get our total cost, 10,890. Our profit markup, which will be 6,000 divided by all the total cost of the first, 6,000 for material, 36 for labor, 154 for overheads, but then you multiply by 10,890. So this work in here simply expresses our what? Our markup, which is profit divided by cost. So that will be 15,246, which is your total what? Your selling price. Which is your selling price, with a profit of 43.56. The fourth bicycle write it here. The fourth bicycle, direct materials is still 6,000. Your labor cost will have to change. The fourth bicycle took how many hours on average? 5 hours, times what? 300. Add your manufacturing overheads. Add your manufacturing overheads, which we know was 150% of your costs, which is 22. That will give you your total cost, to which you're going to add your profit markup. Or if said this markup, you must determine it by taking your selling price, rather your profit, not your selling price, your profit divided by your total costs of the first 6,000 plus 1,500 plus answer 9750. That's 900. So that your selling price, the price of that more bicycle is 13,650. 13,650. Lastly, the price per bicycle if the team places an order for the first 8 bicycles to be assembled. Price per bicycle. Price per bicycle for the first 8. For the first 8 bicycles. For the first 8 what? Bicycles, Let's get our labor cost. But for us to get that, we need to get the labor hours for the first 8. So 12, 8, negative 0.3216 plus 1. 9, not 6, but 9, which is log plus 1, 8 raised to that times 12. So now those are taking 49.142 watts hours, Your cost will be direct materials. Your direct materials will be 6,000 by 8, that is 48,000. Direct labor for the first 8 was 49.152 by what? A rate of 300. 745.6. You need to add your manufacturing overhead costs, which is 150% of your labor. $118.2 for to get your total costs. $84,864. Add your profit markup. 6,000. You express the profit markup as a percentage of costs. So therefore it is 118,809.6. and this is your total sales revenue for the 8 bicycles. So your average price will be 118,809.6 divided by 8, which is 14,851.2 per bicycle. Per bicycle. All right, that is that concept of what? A learning curve. That is that concept of learning curve. Remember we've said that this concept is not not only limited to what we've done here. The other topics in which it relates to, such as budgeting and variances, and also what? Costing pricing methods, and pricing methods. Specifically, they love testing on target costing. They introduce that. All right. So we've come to the end of that. Topic, and goodbye till next time.